Alright, so this is the graphic portion of the GNAW problem, and this is basically a graph, and we have to answer the questions that is involved or included from the graph. So in this problem, we will be finding the answers from the graph. Okay, so let's read the first question. So when is a particle moving right? Now this is kind of confusing because usually the right will be like this way and then that way, but usually the right will be actually going this way since it's the right, you know what I mean, the right place. So it'd be going this way, and then the left part would be going that way. So it's kind of like a little confusing because you see how there's a corner right here and there's a corner right here. So the corner right here will be going right, and then the left, you see the corner right here will be going left. So let me just make points of where the strong points are at, okay? So we have here, a little bit over here, but it's not really at the point. It's kind of like maybe like a 4.7 or 4.8, 4.5, somewhere around that point, right? So it's saying, when is the particle moving right? Now you see how it's 2 over here, right? So it'd be like a, what would it be, like a 0, 0. Okay, and then it's going right here. So going right here, and it's going right here. So it'll be like a 4.7, I guess, right? So let's put that as there. So 0, 0. Oh, my eyes. Okay, no, I'm sorry. Wait, no. It'd be 0, 1. Oopsies. 0, 1. Because right here, okay, and then union, let's do union, which would be 4, I guess, yeah, 4.70. Okay, when is the particle moving left? So left would be going this way. All right, well, if you think about it, going left, right? So we have, I think it's moving 1, so 1, so it'll be like 1 and 4.5, I guess, right? And then when does the particle have the greatest speed? So the greatest speed would mean that it would be starting from here to there, right? So I think that we will put t, and then it will be going there, so like 0, 0 and 2. And this is how you solve a graphic problem. Hey guys, so this is the numeric portion of the GNAW problem, and this problem consists of a table and how we're going to use the derivative from the table and then using rate of change. So we'll be using the rate of change formula, which is f of x minus f of a, and then x minus a, and so on. So let's start by using the formula. So we have p, which is estimate p prime of 15. So if you think about it, p 15 would be like right between 10 and 20, right? Because 10, 15, and 20. So let's make a line here so we can kind of identify where the 15 would be at. So we're going to have to, so between 15 we have 20 and 10 and 150 and 120. So we will be using those 4 numbers and then interpreting into the derivative and then finding the answer. So let's start with the formula. So P20 minus P10 over 20 minus 10 equal to 150 minus 120 over 20 minus 10 is 10. So if you think about it, 150 minus 120 would be 130 over 10. Okay, so that will be basically 3. If you think about it, if you calculate that, it would be 3. And then obviously include the units, which would be people per year. And this is your answer for this problem. Alright, so this is the algebraic portion of the GNAW problem, and this is involved with related rates. So let's start with the problem. So if y squared equals to 3x fourth plus 6x, find dy over dt when x equals to 1 and dx over dt when x equals to 2. When dx over dt equal to 2. Okay, so let's see what we can do first. So what I want to do is that I want to try making it as like organized as possible. So what I'm going to do is that I'm going to try doing the power rule, okay? So I'm going to do 2y dy dt. So remember to not use the prime because we're using dy dt now, okay? Equal to 12 because of the particle x to the third, and then dx dt plus, right? Yeah, dx dt. Plus 6, which is dx over dt. Okay, now let's try solving it. So y squared equal to, it says x equal to 1. So let's try substituting that, okay? 1 to the fourth plus 6, 1. Okay, and well, if you think about it, that equals to 9, right? And 9 square root is equal to 3, so it's just 3. And then let's try substituting that again with the formula all over, okay? So it'll be 2, 3, because y is equal to 3, right? So that's why we would use y as to 3, okay? And then we would use dy dt always equal to 12, 1 to 3. Now we use 1 because x is equal to 1 and x is 1, right? Dx over dt, oh wait, my bad. That would be equal to 2, wouldn't it? I think that would equal to 2. My bad, guys. Oopsies. I was going a little too ahead. So it would be times by 2, and then plus 6, which is 2 again, because dx over dt is 2. That's why I was like, oh wait, let's not put there, let's put 2, because dx over dt is 2. Okay, and then we have that as what? 12, 24, 36, right? 36. So dy over dt is equal to 36. And oh wait, no, I'm sorry. It equal to this. It would equal to 6 because of the square root, and equal to 6. And this is your answer for this problem. Hey guys, so this is the verbal part of the GNAW problem of chapter 4, and this would be basically doing the context of the topic. So this is topic 4.1. So the rate at which Mr. Kelly is buying baseball cards per year is modeled by B times by T, where T is measured in years. Now interpret B prime times of 4 equal to 10. So the main focus of this problem is looking at what they're giving us, which is B times T, and what does B mean and what does T mean, so we can interpret that by solving this. So let's read that problem again and try making it organized, okay? So the rate at which Mr. Kelly is buying baseball cards per year is modeled by B times T. Okay, so we understand that baseball cards, it stands for B, right? Per year is modeled by B times T. Okay, so that means T would be where T is measured in years. So B stands for baseball cards, and T is basically baseball cards per year, which is T, which is the time, which is years. So interpret B times B prime. Think about the prime. Prime is derivative of 4 equal to 10. Okay, so let's see where we can do this. So the rate of change of the rate. Now I say of the rate because it already mentions the rate at which Mr. Kelly is buying baseball cards. So that's why I say the rate at, because the rate of change of the rate, because like they already mentioned the rate, so we just do that again. Okay, the rate of change at the rate at which Mr. Kelly is buying baseball cards is 10 cards, 10 cards right here, per year / year again, because it's per year, at T equal to, so T is 4, because B times T is the model, right? So T equals 4 years. And this would be your answer for this problem.